NENOMATICA, where mathematics meets YouTube excellence. In this example, we will follow a clean, rule-driven path to simplify a sum of rational expressions. Every step mirrors the printed solution, with clear reasons and highlights. First, we mark this as an example. Then we state the problem itself in bold orange math. Quick challenge: can you predict the common denominator we will use? Step 1. We bring all three fractions to a single common denominator. The common denominator will be the product of all distinct linear factors, b minus c, c minus a, and a minus b. We multiply each fraction by 1 in a way that introduces the missing factor to its denominator and the corresponding factor to its numerator. Step 2. Notice each highlighted product is of the form sum times difference, which is precisely the difference of squares. We now rewrite those three products using the identity a plus b times a minus b equals a squared minus b squared. Step 3. Now observe the telescoping behavior. A squared cancels with negative a squared, b squared cancels with negative b squared, and c squared cancels with negative c squared. The entire numerator collapses to 0. Finally, 0 divided by any non-zero denominator is simply 0. That completes the simplification. Here is the problem statement in bold orange. Then we start with step 1. Step 1. Rewrite the third denominator using the difference of squares identity. A squared minus b squared equals open parenthesis, a minus b close parenthesis times open parenthesis, a plus b close parenthesis. We only change that denominator and highlight it in orange. Step 2. Combine all three terms over the common denominator open parenthesis, a minus b close parenthesis times open parenthesis, a plus b. We will multiply the first numerator by a minus b and the second numerator by a plus b, leaving the third as is. All changes will be colored orange. Step 3. Apply the special products. Open parenthesis, a minus b close parenthesis times open parenthesis, a squared plus a b plus b squared equals a cubed minus b cubed. An open parenthesis, a plus b close parenthesis times open parenthesis, a squared minus a b plus b squared equals a cubed plus b cubed. Then expand the combined numerator explicitly. Step 4. Combine like terms in the numerator carefully. The a cubed minus a cubed cancels to 0. The minus b cubed minus b cubed plus 2b cubed also becomes 0. What remains is a squared minus b squared. Step 5. Notice the numerator a squared minus b squared equals open parenthesis, a minus b close parenthesis times open parenthesis, a plus b. It cancels with the denominator, and the entire expression equals 1. Now, step 1. Express the sum and difference using a common denominator, namely open parenthesis, a plus b close parenthesis times open parenthesis, a minus b close parenthesis. Rule reminder: use the distributive property to expand each product. Step 2. Expand all four products in the numerator carefully. Rule reminder: when subtracting a group, distribute the negative sign to each term inside. Step 3. Remove parentheses and combine like terms carefully with correct signs. Rule reminder: group like terms for a squared, ab, and b squared, then add their coefficients. Step 4. Combine like terms in the numerator. Rule reminder: difference of squares factors as open parenthesis, a plus b close parenthesis times open parenthesis, a minus b close parenthesis. Step 5. Factor the numerator and cancel with the denominator to get 1. Quick challenge: why did the ab difference of squares factors as open parenthesis, a plus b close parenthesis times open parenthesis, a minus b close parenthesis. Step 5. Factor the numerator and cancel with the denominator to get 1. Quick challenge: why did the AB terms cancel out completely? Think about the symmetric positives and negatives created by distribution. Summary: we applied the rule for adding and subtracting fractions with different denominators, expanded with the distributive property, combined like terms carefully, recognized the difference of squares, and simplified to 1. Combined like terms carefully, recognized the difference of squares, and simplified to 1. Example: we will simplify the given algebraic expression step by step, exactly matching the provided structure. Problem: simplify the expression. We keep all math bold and clearly visible. Adding and subtracting fractions. We use the identity A over B plus or minus C over D equals add plus or minus BC all over BD. Step 1. Combine the fractions inside the first parentheses by creating a common denominator. Rewrite the subtraction as a single fraction. Also, combine the terms in the second parentheses over a common denominator of 4x. Expand and simplify polynomials. We use the identities for squares and distributing the subtraction. Step 2. Expand the numerators and simplify. First, expand the first numerator and combine like terms. Next, simplify the second numerator. Rewrite the entire product accordingly. Difference of squares. We use the identity a minus b times a plus b equals a squared minus b squared. Step 3. Simplify the denominator and factor the numerator. Notice that 1 minus x times 1 plus x equals 1 minus x squared, and factor 3 times 1 minus x squared from the second fraction. Rule. Cancel common factors. If a common factor appears in numerator and denominator, we can divide both by that factor. Step 4. Cancel the common factors 4x and 1 minus x squared, leaving the constant 3. Final answer. The entire expression simplifies to 3. Here is the example. We will keep the entire expression bold and highlight important changes in orange as we proceed. Step 1. Factor each denominator where possible. 2a minus 2b becomes 2 times a minus b. 2a plus 2b becomes 2 times a plus b. And a squared minus b squared is the product of minus b times a plus b. Step 2. Combine the three fractions inside the parentheses over the common denominator 2 times a minus b times a plus b. Adjust each numerator accordingly. Step 3. Expand the two squares using the identity. A plus b quantity squared equals a squared plus 2ab plus b squared. A minus b quantity squared equals a squared minus 2ab plus b squared. Step 4. Combine like terms in the numerator. The difference of the two trinomials yields 4ab, including plus 4b squared gives 4ab plus 4b squared. Step 5. Factor out the common term 4b from the numerator to get 4b times a plus b. Step 6. Cancel the common factors. The factor a plus b cancels. 4b over 2 simplifies to 2b. Then 2b over 2b cancels with the second fraction, leaving exactly a minus b as the final simplified result. We display the example and the problem statement in bold orange math. Step 1. Rewrite every fraction with factored denominators and align our terms. We'll keep everything bold and just set the stage for combining them later. Step 2. Put everything over the single common denominator 2 times x minus 1 times x plus 1. Watch the numerator terms in orange. Those are the changed parts created by the common denominator. Step 3. Expand the binomials using the square formulas. We will color the expanded pieces in orange. Step 4. Combine like terms inside the numerator. Notice how x squared cancels with negative x squared, and 2x minus negative 2x becomes 4x. We also carry along negative 8x and plus 2x squared and plus 2. Step 5. Rearrange terms into standard polynomial order. 2x squared minus 4x plus 2. Step 6. Factor out a 2 from the numerator. Step 7. Recognize the perfect square in the numerator x squared minus 2x plus 1 equals quantity x minus 1 squared. Step 8. Cancel the common factor of x minus 1 between numerator and denominator to get the simplified result. In this example, we will simplify a rational expression step by step using factoring, common denominators, and cancellation. Then we will combine all terms over a shared denominator and reduce the result carefully. First, we notice the denominators. The most complicated one is a to the fourth minus b to the fourth, which factors as a minus b times a plus b times a squared plus b squared. We will bring every term over the common denominator, which is the product a minus b times a plus b times a squared plus b squared. Now we write each fraction over that common denominator. The first term over a minus b must be multiplied by a plus b times a squared plus b squared. The second term over a plus b must be multiplied by a minus b times a squared plus b squared. The third term, 2a squared over a squared plus b squared, must be multiplied by a minus b times a plus b. The last term already has the full denominator after factoring. We now combine them as a single fraction. To simplify the numerator, we can either expand and combine like terms or factor smartly before expanding too much. Notice the first two terms both have a times a squared plus b squared, and the third term has a minus b times a plus b, which equals a squared minus b squared. Let's use these observations to reduce the work. Combine like terms. -2 a squared b squared plus 4, a squared b squared becomes +2 a squared b squared. Then we can factor a squared plus b squared out of the remaining two terms. Now factor out 2a from the binomial. Then the entire numerator is 2a times a plus b times a squared plus b squared. Since the denominator is a minus b times a plus b times a squared plus b squared, we can cancel the common factors a plus b and a squared plus b squared. The simplified result is 2 over a minus b. Quick challenge. Which two factors did we cancel in the last step? Now, let's challenge. Which two factors did we cancel in the last step? Now, let us summarize the key ideas from this solution. Welcome! In this example, we'll simplify a complex fraction step by step using clear rules and careful highlighting for each transformation. Our goal is to follow the structure shown and correct any mistakes minimally if needed. Here is the example. Problem: simplify the expression. We will keep all mathematics in bold latex and highlight changes in orange as we go. Step 1. Write the original expression clearly and note that we will enforce domain restrictions later. Step 2. Combine the two fractions in the numerator over a common denominator, then apply the difference of squares identity. A squared minus b squared equals a minus b times a plus b. Step 3. Simplify each factor in the denominator. First factor, open bracket, 1 plus x over 1 minus x, minus 1, close bracket. Second factor, 1 minus 1 over 1 plus x. Step 4. Rewrite division as multiplication by the reciprocal, and then cancel common factors carefully. Step 5. Cancel the common factor, 1 minus x times 1 plus x, and then simplify the numeric and variable parts. Step 6. Simplify 4x over 2x squared to 2 over x. Note, some sources incorrectly collapse this to 1, but the correct simplification is 2 over x. Before we celebrate, enforce domain restrictions from the original expression x cannot be plus or minus 1 because of denominators, and x equals 0 makes the original denominator vanish. So the domain excludes -1, 0, and 1. Quick challenge. Can you explain why x equals 0 is excluded by inspecting the original denominator factors? Take a moment to reason that through. Final answer. Summary. We combine the numerator using difference of squares, simplified the denominator factors, turned the division into multiplication by the reciprocal, canceled common factors, and obtained 2 over x with proper domain restrictions. Then the problem in bold, orange latex. Step 1. Combine the fractions over a common denominator. We use the rule for adding and subtracting fractions with a common denominator. Notice that the third denominator b squared times open parenthesis, b squared minus a squared close parenthesis, can be rewritten as negative b squared times open parenthesis, a squared minus b squared close parenthesis. So all fractions can share a common denominator of a squared b squared times open parenthesis, a squared minus b squared close parenthesis. Step 2. Express all terms with the common denominator and combine the numerators. We use the rule for a common denominator for addition. Step 3. Expand all products in the numerator using the distributive property. Step 4. Distribute and simplify the numerator terms, then combine like terms. Step 5. Cancel terms and simplify the numerator. Many terms cancel in pairs, and the result becomes b squared a to the fourth minus a squared b to the fourth all over a squared b squared times a squared minus b squared. We then factor the numerator as a squared b squared times a squared minus b squared. Step 6. Factor numerator and denominator. The numerator and denominator are identical, so the entire fraction equals 1. We will simplify a symmetric algebraic expression and show, step by step, that it equals 1 for distinct values of a, b, and c. Let's begin with the example prompt. Important note, a, b, and c must be distinct so that the denominators are non-zero. Step 1. We add fractions by moving to a common denominator. Watch how we build the common denominator and adjust the numerators accordingly. Step 2. Expand the binomials using the product expansion identity. Step 3. Distribute the outside factors. Notice something elegant. The coefficients of x squared and x cancel out completely, leaving only constant terms in a, b, and c. Quick challenge. Why do the x terms cancel? Hint. This is a classic symmetric identity connected to interpolation and the Vandermonde structure. Step 4. Group like terms to factor. Step 5. Factor out common terms. Each group shares a factor of b minus c after reorganization, giving a common b minus c in the numerator that cancels with the denominator. Step 6. Group terms to prepare for a final factorization. Step 7. Factor each group. Note that c minus equals -1 times a minus c. This reveals a common factor of a minus c, producing the product a minus c times a minus b. Step 8. Cancel the common factors a minus c and a minus b in numerator and denominator to get 1. Great job! Before we wrap up, can you articulate in your own words why the x terms must cancel? Take a moment to think about symmetry. In this lesson, we will simplify a symmetric rational expression and show that it equals 0. Here is the expression. Our goal is to combine the fractions, simplify the numerator, and show the result is 0. Step 1. We will rewrite each term to share the common denominator. Open parenthesis, a minus b close parenthesis times open parenthesis, a minus c close parenthesis times open parenthesis, b minus c close parenthesis. Notice that b minus equals -1 times a minus b, and c minus equals -1 times a minus c, and c minus b equals -1 times b minus c. So the second fraction picks up a negative sign. The third fraction keeps its sign because the two negatives multiply to a positive. Now, we combine all three terms over the common denominator. The common denominator is open parenthesis, a minus b close parenthesis times open parenthesis, a minus c close parenthesis times open parenthesis, b minus c close parenthesis. The combined numerator becomes open parenthesis 1 plus a close parenthesis times open parenthesis, b minus c close parenthesis, minus open parenthesis, 1 plus b close parenthesis times open parenthesis, a minus c close parenthesis, plus open parenthesis, 1 plus c close parenthesis times open parenthesis, a minus b close parenthesis. Next, expand the numerator using the distributive property. We get b minus c plus ab minus ac, minus a minus c minus ab plus bc, plus a minus b plus ac minus bc. Now remove parentheses and combine like terms carefully. The numerator becomes b minus c plus ab minus ac, minus a plus c minus ab plus bc, plus a minus b plus ac minus bc. We will now pair opposite terms to visualize cancellation. Each pair sums to 0, so the entire numerator is 0. Therefore, the whole fraction equals 0 divided by the common denominator, which is 0. So the expression simplifies to 0. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.